Before we get into the details of how master node communication happens in a Kubernetes cluster, let's understand why we should even care. There are two reasons why it's important for us to understand master node communication. The first is simply for knowledge so that we clearly understand the inner workings and architecture of Kubernetes. The second has to do with the security implications. As we shall see, there are some aspects of master node communication which are not very secure by default, and we then might want to mitigate those security considerations either by moving to a public cloud platform or by tweaking the configuration settings of our Kubernetes cluster to tighten network security. So this is why we should care about how master node communication happens. Let's now plunge into how that communication happens. Let's break this down into two parts. Let's start with communication from the cluster to the master. Recall that the master or the control plane in a Kubernetes cluster has various components: the API server, the etcd or the cluster storage component, the scheduler, and the various controllers. All communication from the cluster to the control plane is going to only happen or only terminate at the API server. None of the other master components should ever be talking directly to the other components in our cluster. The API server is going to be configured to listen for remote connections on HTTPS, that is 443, and typically client authentication is going to be enabled. You might also want to make sure that your nodes have been provisioned with the appropriate public root certificates and take care of other security aspects within your cluster. But the bottom line is that communication from the cluster to the master is going to be secured, and therefore you can assume that this can run over untrusted or public networks without your taking a whole lot of special actions. Let's now turn to communication from the master to the cluster, and this is a lot less secure by default. This is where it's important for you to have your eyes and ears open. Communications from the master to the cluster can further be split into two types: communications between API server to the kubelet, and communications from API server to nodes, pods, or services. Let's start with the communications from API server to the kubelet. These communications by default are not going to be safe. That is because the API server is by default not going to verify the kubelet serving certificate, and so these communications are vulnerable to man-in-the-middle attacks. Therefore, API server to kubelet communications should not run on untrusted or public networks. In order to change your cluster configuration so that this certificate or this connection of the kubelet is verified, you've got to use a specific flag, the kubelet certificate authority flag. You might also want to make use of SSH tunneling as an alternative to verifying the certificate. This will create a secure connection from the API server to the kubelet. And now turning to communication from the API server to the individual nodes or the pods or the services. Well, these are extremely unsafe currently. That's because all of these are just default plain HTTP connections and are therefore neither authenticated nor encrypted. You could go ahead and tighten this by making use of a public cloud platform such as the Google Kubernetes engine. This is going to set up SSH tunnels in order to protect all communication from the master to the cluster. But again, you should be aware that by default, communication from the master to the cluster, and in particular communication from the master to the individual nodes, pods, or services, is not currently safe to run over public or untrusted networks.